In this video, we're going to be looking at alkenes. Alkenes are unsaturated and they have a double bond. The reason we've got a picture of a banana is because bananas release a chemical called ethylene, or IUPAC name is ethene, and this causes ripening. So alkenes are a hydrocarbon that contain at least one double bond, and the molecules are said to be unsaturated. So olive oil is mono unsaturated, that means it contains one double bond, and margarine is poly unsaturated, which means it contains many double bonds. So let's look at how to name an alkene. So the first thing is you need to find the longest carbon chain containing the double bond. So the functional group here is the double bond. So we need to make sure this is included in the main chain. Now the longest carbon bond is 1, 2, 3, 4, 5, and this would be numbered in this direction to make sure the double bond is at the lowest position. Now we have a branch here, and we have a functional group in prefix here. So let's name the parent name. It is pent, and you put 1-ene. So this means the double bond is located between carbon number 1 and 2. We have a branch which is a methyl group, so we put that in, methyl, and it is located on carbon number 4, and we have a functional group in prefix which is a bromo, and it is located on carbon number 5. Now remember, between numbers and numbers we have commas, and numbers and words we have a dash. And we need to check for cis trans. Now as carbon number 1 both contain a hydrogen, there cannot be cis trans isomerism in this one. Your task is to try naming these alkenes. Stop the video and have a go. So to name it, find the chain with the longest chain with the carbon-carbon double bond, which is this one. 1, 2, 3, 4. I've numbered it, and I can see the parent name then would be bute 1-ene. I only have a functional group in prefix, which is a chloro, and it's on carbon number 1. Now I need to check for cis trans isomerism, so I cover everything but carbon number 1, and I can see there are two different things, a hydrogen and a chlorine. Then I cover everything, cover carbon number 1, and I can see for carbon number 2 we've got two different groups. So this has the potential for cis trans isomerism. Now we look at carbon number 1 and 2 and see if there is a group that is common, which in this case is the hydrogens, and we can see this crosses the double bond like a train track, so it's crossing the train track, so it's trans. Now try naming this alkene. Stop the video and have a go. So we want the carbon-carbon double bond in the lowest position. Now 1, 2, 3, 4, 1, 2, 3, 4. Now I'm going to number this way because it puts the chlorine also in a lower position. So this is a bute, and the carbon-carbon double bond is on carbon number 2. So bute 2-ene, that means it's between carbons 2 and 3. I have a chloro group, which is a functional group in prefix, which is number 1. Now I need to check for cis trans isomerism, so I cover carbons 3 and look at carbon 2, and I've got two different groups here, this and this. and I cover carbon number 2, and I can see I've got 2 different groups here. Now I need to see if there's a group that repeats, and I can see here the hydrogens repeat. It's giving me a smiley face, so this is a cis isomer. Try naming this alkane, stop the video and have a go. Okay, so we need to number so that the double bond is in the lowest position. 1, 2, 3, 4, 5. So it's a pent. And the carbon-carbon double bond is on carbon 2. So pent 2ene. I can see I have a bromo, which is a functional group in prefix, and that's on carbon number 4. And now I'm checking for cis-trans isomerism. And I've got a hydrogen and hydrogen here. It's going to be a cis isomer. Now I'd like you to have a go at drawing alkenes. So, drawing the parent chain first. You should be drawing them on an angle. So start by putting in the double bonds, and they're going to come off at an angle of 120 degrees. So you need to draw it like this. So this is a pent 1ene. So 1, 2, 3, 4, 5. So carbon number 1, carbon number 2, carbon number 3, carbon number 4, and carbon number 5. Now I'm going to add my substituent groups or functional groups in prefix. So 3 is methyl, so I'm going to put a carbon off it. And then I have a chloro on number 1. And I have to check this here. The chloro, it says it's in cis, so a chloro can't be there. It has to be here so that my hydrogens will be in a cis configurations. Then I'm going to add all my hydrogens so that the carbons are satisfied their 4 bonds. And then we have it. Now I'd like you to try the following ones. Remember, draw the double bond on the angles and stop the video and have a go. Now let's draw the answers. So start by putting in the correct angles around the double bond. So this is carbon number 1, 2, 3, 4, 5, 6. Now complete your hydrogens to satisfy carbon's bonding requirements. Now you'll notice that on carbon number 1 there are 2 hydrogens, so this means it is incapable of doing cis-trans isomerism. Number 2, 3-methyl pent 1ene, so draw the angles 1, 2, 3, 4, 5. On carbon number 3 we have a methyl group. Now draw in the hydrogens to satisfy carbon's bonding. You'll notice around carbon number 1 there are 2 hydrogens, so this means it's incapable of cis-trans isomerism. Next one, trans 1-bromo 4-methyl pent 2ene. So put your double bond in. It's a trans. So this means it's going to go across the double bond. And I'm going to put the 2 things that'll go across, which will be the hydrogens. I'm going to have a bromo on carbon number 1. 1, 2, 3, 4, 5. On carbon number 4 we have a methyl group. Now put in the hydrogens to satisfy carbon's bonding. And this is a trans isomer because it's going across. I'd like you to try some for yourself. Go to the OneNote and try some name and draw alkenes.